Hi. So, what is permutation? Permutation is the act of changing the arrangement, especially the linear order of a set of items. So, what is the difference between permutation and combination? For an easy way to understand this, if the order doesn't matter, then it's combination. But if the order matters, it's permutation.
Go. For example, we have a safe, and the only code to unlock the safe is 123. Then, only that set of numbers unlocks the safe. If we use 213 or 312, it won't open. 123 works because this is the set of numbers exactly made in order. Therefore, having order makes this valid for permutation.
Okay, so to further elaborate what permutation and combination is, we need to study what is factorial function. So the factorial function is represented by this symbol, or mainly known as the exclamation mark. Now, it says to multiply a series of descending natural numbers. So what does this mean? For example, my examples over here are 4 factorial. That's equivalent to 4 times 3 times 2 times 1. You can see the pattern over here that it is the numbers below number 4. It is multiplied to the numbers below number 4, to be exact. So to basically summarize it up, it's multiplying the main number that you chose to the numbers below it. For example, 7 factorial. That's 7 times 6 times 5, 4, 3, 2, and 1, and that's equivalent to 5040. So if I had, for example, 5 factorial, that would be 120. If I had 3 factorial, that would be 6. So to help you guys figure out how to do factorials in your calculator, you'll be seeing this symbol over here. Now to access this symbol, you need to press shift, and that's how you get the factorial symbol. I do hope you guys can see it. So for example, my example over here is 4 factorial. That's 4 factorial, and we get 24. Okay, so now that we've tackled about factorials, let's go back to permutation and combination. Over here we have the shortened formula for permutation. Over here we have the shortened formula for combination. Over here we have the extended version of it. It's well formulated and well elaborated. Over here we have the combination formula. So what is n and what is r? So n is our set size. N correlates to this, and r correlates to this. So what is the difference? The set size is the total number of items in the sample. The subset size is the number of items to be selected from the sample. So we all know that our set size is 4. Now the subset size is 4, 3, 2, and 1. Now we all know that this is equivalent to 24. But what if we don't want number 1 to be included? So that will just make up 4 times 3 times 2. Now what if we don't want 2 and 1 to be included? So that will just make 4 times 3. Now that is the importance of the formula itself. Okay, so over here we have another set of examples for permutation and combination. Now we have 5 factorial 3 and 5 factorial 3 for both examples. Now we know that 5 factorial is made out of 5, 4, 3, 2, and 1. 5 factorial is equal to is multiplied to the numbers below 5 itself. Now 5 will be our set size, as stated here, n. Set size is n. Now Now, our set size is the total number of items in the sample. This is our subset. This is also considered as our sample. So we have 5, 4, 3, 2, 1. These are 5 numbers, and our set size is 5. So, what is the use of the subset? The subset is made out of 5 numbers, right? But what if we only need or want a selected number of a selected number of our subset? For example, I only want 3 numbers, then we only have to go with 5 times 4 times 3. If I want to go with 4 numbers, I will have to go with 5 times 4 times 3 times 2, and then so on and so forth. As the number goes higher, our subset grows larger. So now we're going to solve for 5 factorial 3. Now we know that the numbers below 5 are 4, 3, 2, and 1. So now I chose to only have 3 numbers of it. So it's going to work out like this. 5 times the next number below it, which is 4, and then 3. Now I have 3 items that I want to 3 items of the factorial of the number that I want to multiply. So we know that the answer to this is 60, because 5 times 4 5 times 4 is equal to 20, and 20 times 3 is equivalent to 60. So 60 is the answer to this question. Now, combination is a little bit more complicated in a sense that we're going to have to use the formula for permutation. Now, to solve for 5 factorial 3 in combination, it is equal to 5 factorial 3 over our subset. So that's 3. Now we need to factorial 3 as well. So what are the numbers below 3? So the numbers below 3 are, as it says, 3 itself times 2 times 1. Now we have 3. Then we're going to go back with 5 factorial 3. So it goes with the same number as we had here. That's 5 times 4 times 3. So the next thing over here is we're going to be solving it. Since 3 and 3 cancels each other out, we'll have to cancel that out. And since 2 and 4 are divisible, we're going to cancel that out. That leaves us with 2. Now 5 times 2 is equivalent to 10, and what's left over here is 1. So simplifying this, the answer will be 10. So the answer to 5 combination factorial 3 is 10. This is why solving for combination is a little bit more complicated, is because we actually need to use the formula, a part of the formula of the permutation. Now, to help you guys solve in your calculator, open your calculator and we'll be solving for both permutation and combination. So I'm using Akasha over here, which only displays a single line of digits, and using a calculator that is more complex will actually make it more easier. But to show to those that actually have the same type of calculator as I have, this is how we do it. So 5 over here, you see the formula for permutation and combination. Now that's 5 shift, we get P. Now our subset will be 3, so that equals to 60. I do hope you guys can see it. Now going back to combination, that goes for the same way. 5 combination goes with the letter C, and then 3. And we get that. So to wrap things up, this is the formula. This is the formula for permutation, and this is a formula for combination. Factorial is the symbol for the numbers below a number. Now, for example, 6, that's, 6 factorial, that's equivalent to 6, 5, 4, 3, 2, 1, that goes for 7 factorial, that's 7, 6, 5, 4, 3, 2, and 1, so on, so forth, and that's it.